All right. How's it going on? Hopefully you can hear me all right and you can see everything that's going on. Right. Okay. Wicked. So from what I can gather, you want to go over some database normalization stuff. You want to go over SQL. You want to have a look at some networky stuff, URLs, etc., etc. So I guess let's just see where. Sorry, I'm just looking at the. Did Tyler really forget to unmute his mic? Or okay, anyway, right. Hello, sire. Yes, nice to see you. You pay me the correct amount of deference. So maybe we could start with. Oh, it was all George's fault. Wicked. Okay, cool. At least I know now. Hey, look, I knitted this. What is this, you might ask? Well, hope you're ready for this. How about that? Huh? How about that? Yeah, I knitted that. Skills. I also crocheted a little scarf for Master Chief here and a hat. Right. Anyway, let's enough of my silly posturing. Let's get on with something. So, database normalization. Is there something specific related to normalization that you want to go over, or do you just want to have a quick overview of the whole lot? How do you want to tackle this? I hope you can see my new mug as well. It's a Mavio cuffed mug. Acid is not part of database normalization, but we still go over acid. Shall we just have a quick look? Kira can't speak. Roadman. Yeah, good. I mean, I'm not sure if. I believe what Kira said would almost pass muster. Well done, sir. You've got them mad skills, bruv. In it. First normal form, second normal form, third normal form. Okay, cool. We'll go through this. Right. So I don't need to. Do I need to go over entity relationship diagrams? Or are we good on entity relationship diagrams? Now we're good. Right, cool. Okay, let's just skip on past that. We know about composite keys, right? What makes many-to-many relationships actually bad? Well, if we have a look at this many-to-many relationship here, we know that each film contains many actors, and each of those actors could be in many films as well, which in and of itself isn't necessarily a bad thing, but it does mean that if we've got some other relationships down here, then it muddies the water a little bit to find out how specifically different relationships are formed. And it also can lead to data redundancy, duplicate data. Remember, that's the whole point of database normalization. It's to eliminate redundancy. And if you have one film containing multiple actors, you also have those multiple actors in multiple films. It stands to reason that inside your film, you're going to have duplicate actor IDs, right? If you've got a film and you have the actors that were in that film, you're going to have IDs of the same actors that were in like, you know, the same films and vice versa, right? And so splitting it out so that we have a one-to-many and a many-to-one relationship there, it reduces the amount of data duplication. That's the thing. Now, here's the thing as well, right? We talk about composite keys, yeah? Here is my bridging table, my link table. Film ID 0, actor ID 0, they correspond. Film ID 1, actor ID 1. Film ID 0, actor ID 2. Film ID 1, actor ID 3. Remember, with a composite key, it's the combination of both of those IDs which forms the primary key. That is the uniqueness. Because you notice that 0 and 1 in both of these, they are not unique, but there is only one combination of 0 and 0 together. There is only one combination of 0 and 2 together. So that combination there becomes unique, and that's why we have that's where we get composite keys from. For some reason, OBS is eating up most of my CPU. I don't know what's going on there. I'll sort that out. So yeah, composite keys and composite keys. That's what, you know, how there's often a lot of confusion about what the difference is between second normal form and third normal form. A lot of the time, you end up, if you normalize from first to second and you don't have composite keys, you'll often find that your stuff ends up in third normal form anyway. But we'll get onto that. So redundancy, and we're eliminating redundancy. We're maintaining consistency. Right, so first normal form. First normal form, this is where all fields must be atomic. So each field can only contain a single item. That means no fields that have multiple items in them, and also no repeating groups of columns, right? So that means if you have a film with multiple actors in, you wouldn't have the film ID and then actor ID separated by commas, you know, like Raiders of the Lost Ark stars Harrison Ford. Who the hell else is in Raiders of the Lost Ark? Let me find out. IMDb will answer this. IMDb Raiders of the Lost Ark. Who else is in it? Is John Reese? What's his name in there? Is Gimli in it? Harrison Ford, Karen Allen, who plays Marion. So Harrison Ford, Karen Allen, Paul Freeman, who played Belloc, Ronald Tracy. Yes, John Rhys Davis, who played Salah in Raiders of the Lost Ark, and also is it Gimli, dwarfy dude from Lord of the Rings. So you wouldn't have one column that lists all of those separated by a comma. You also would not have multiple columns like Actor 1, Harrison Ford, Actor 2, Karen Allen, Actor 3, Paul Freeman, etc., etc. Okay, is that a relation of Morgan Freeman? I don't think so, because he's white, and Morgan Freeman is not white. But Freeman is a fairly common name. So you've seen Raiders of the Lost Ark, right? You know who Belloc is. If you haven't seen Raiders of the Lost Ark, what are you doing with your life? It's the best of the 3 Indiana Jones films. An example of something bad here. We've got our truck ID. We've got the name of the truck. We cannot have this. Look, Jenkins, Thompson, Hercules. Now, no doubt they are all crew members on the Heidegger. Berkowitz and Harrison, they are crew members on the Verizon, but we cannot have multiple crew members. That is not an atomic field. Make sense? Yeah, Drake says no. Oldmemes.com. Likewise, this is also wrong. Crew member 1, crew member 2, crew member 3. Cannot do that. For the basic reason that what if you, like in this example, look, we've only got 2 crew members on the Verizon, so we have this like blank hole here. What if we have a truck that has a crew of 5 or 6, so on and so forth? Okay. So, how do we fix it? This is how we fix it. Multiple tables. Okay, so if you had, for instance, a table like this, and it said, explain why the table is not normalized, then you could explain, well, there's multiple there's multiple columns, repeated columns. So no. What would you do in order to put it into first normal form? You create two tables, one with the truck ID and the name, and one with the crew. So we've got crew ID 1, name is Jenkins, and the truck ID is obviously a foreign key from the truck table. Does that make sense? This thing is really warm. Can't believe how warm it is. It's so warm I might have to take it off. So bear with me while I do that. We good? Give me a thumb or similar gesture to indicate that you get, well, it is summer. Your summer. What's that film? That is it 365 Days of Summer? Is that what it's called? 300 Days of Summer? I can't remember. Again, IMDb. 500 Days of Summer. 500 Days of Summer. Great film, by the way. Not just because it's got Zooey Deschanel in it, but yeah, good film. Anyway, I'm getting off track here. So first normal form, boom, wicked. Okay, Drake approves. You cannot judge a film based on the name of the film, right? For example, Dune. Well, that sounds like a perfume. In fact, there is a perfume called Dune. 500 Days of Summer is about a guy who falls in love with this girl called Summer. Although, has he actually fallen in love with her, or is he just sort of like wildly attracted to her because he likes the idea of her? And it's one of my favourite. I don't like romantic comedies because I think they're awful, but I think it's very good because it has an accurate view of romance. And in that things don't like pan out. You should watch it. It's good. And it's got Zooey Deschanel in it as well, who's a very attractive young woman. She's not that young anymore, but she. Experiencing 500 Days of Summer wouldn't be fun. I beg to differ. I beg to differ. That's like 1.5 years of summer sounds good to me. Anyway, so second normal form. The first requirement for a table to be in second normal form, or for a database to be in second normal form, is that it must first already be in first normal form, right? And don't just think, well, that's obvious, right? Or make sure if you're explaining this, you write that down, yeah? Because I know it sounds obvious, but just remember, we are computer scientists, right? If we're explaining something to a computer, we cannot allow for any kind of ambiguity. And therefore, when we are explaining things like this, we can't allow for any ambiguity either. Phineas and Ferb is that one with the kid with the triangular head. Is that right? No, I don't know. All non-key fields must be dependent on the primary key, right? So each table must be about one thing, must only be about that one thing. Let's have a look at this, right? We've got an example table here. Well, you tell me, what's the primary key in this table, and what should this table be? What should all of the things in this table be related to? You tell me. And can you also pick out the odd one out? What thing is not related to the ID? Yeah, truck ID is the primary key. Okay, so everything in there, every one of these attributes needs to be an attribute, or it needs to be dependent on this truck ID. So, which one? You're absolutely right. Parking bay. Parking bay is not related to truck ID. By the way, when we're talking about like things having to be dependent on the primary key, what we mean is non-key values or non-key values. Now, at the moment, parking bay is not a key value. It's not a foreign key imported from a second table. It's just an attribute in here saying, oh yeah, if you're in this truck, you park in this bay. Okay. So, how do we fix it? Another table. Okay. We have our truck ID, all of the attributes in this table, which are not key attributes, are dependent on the primary key. The name of the truck, the top speed of the truck, the color of the truck, right? And then we have this separate table, parking bay ID. So we've got parking bay 12 has the ID 12. I mean, it makes sense for the primary key to be based on what the parking bays are actually called, and then the truck ID, that is a foreign key from over here. So, okay, so before you start crying foul and saying, "Oh, well, truck's not dependent on parking bay," yeah, well, here's the thing: that is not a non-key value. There are, in fact, no non-key values in this whole table. Obviously, in a real world situation, you probably would have, but in this example, we don't have. Does that make sense for your second normal form? I was going to cry. I mean, it's not that bad, you know. We haven't even got to third normal form yet. There we go. I'll put that on the back of my book, shall I, George? Cool. So Drake approves. Right, third normal form. The third normal form, it must already be in second normal form. Okay, and therefore it must already have also been in first normal form. All non-key attributes must depend on the primary key, the whole primary key, and nothing but the primary key. So help us God, right? So if we've got a composite key, right, the non-key attributes must be dependent on both parts of that primary key. Yeah. The easiest way of thinking about this is like no derived attributes, right? No attributes that if you took away the primary key, you'd still be able to work them out from other keys, other values which are in the table. Yeah. So as an example, which of the following columns is an example of a derived attribute? Age, yes. Even if all of this data here was destroyed, if we still had the date of birth, we could work out the age. It doesn't need to be in there, right? Remember, we're trying to cut down on the amount of data that we're storing. If we can calculate data based off some other value, then why not do that? Just store that value. We can calculate that. Okay. Truck ID is obviously that is not a non-key value. It's a foreign key imported from another table. How does this differ from second normal form? Second normal form, you can have these derived attributes in here. Okay, so this would fit second normal form. This would fit second normal form, right? The age is dependent on the crew ID. Yeah, the date of birth is dependent on the crew ID. But the thing is, age can also be derived from date of birth. You know, so this table as it stands here would fit with second normal form. It doesn't fit with third. Okay, the age column is an outlier. So all we have to do there is just cut it out. We've got this is a slightly more tricky one. I don't know if you can remember this from before. Truck ID is the primary key here. There's a couple of columns here. Which are columns that are not dependent on the primary key, or can be derived from something else, and it's not immediately obvious. Can you any ideas? give you a clue. I'll give you a clue. Not color. You can have multiple different colors, and you could respray the truck. If I was to say, I got a brand new Corsa, or I got a brand new Astra. Yeah. George is exactly right. If you know the model, then you know who makes it, right? But also the top speed. The top speed is dependent on the model as well. Yeah? If I've got a Cobra Mark III, that's got a top speed of 50. If I've got an Asp Explorer, that's got a top speed of 12. That's not related to the truck ID itself. It's related to the model that I've got here. Okay? So make is dependent on model. Top speed is also dependent on model as well. The color is specific to this truck. The name is specific to the truck. The top speed is specific to the model the truck is. Does that make sense? So again, how do we fix it? This was the example with the age. So all I've done is remove that age column. And this example with the make and the top speed, we separate it out into a couple of extra tables. So you can see here, nice third normal form. We have our primary key. All of this information, all of the non-key attributes are related to the truck ID. We have a foreign key imported from the model table. So the model table, the primary key is model ID. Top speed is dependent on the model. The actual name of the model is dependent on the model ID as well. There's also this foreign key imported from the make table, and inside the make table we've just got the make Falcon DeLacy and Lacon. They are dependent on the make ID. So the solution is usually add tables. Yeah, the solution is almost always add more tables. The trick is, how do I structure those new tables that I add? You'll find if you've drawn decent ERDs, a lot of the time the tables that you produce from your entity relationship diagrams tend to be reasonably well normalized anyway, because like you eliminate things like fan traps and whatnot during that process. Does that make sense in terms of normalization? Yeah. I don't think we need to go through any of that lot. That's normalization in a nutshell. Is that good? The confusion tends to be between, like, what's the difference between second normal form and third normal form? Fan traps. A fan trap is one of those. That's a fan trap. It's called a fan trap because look, it looks like you got these two fans, like a Chinese finger trap. That's a fan trap. Remove them like that. Yes, Amy. I know you love database normalization. I know you love it, and you're intimately familiar with it. Cool. So we're done normalization. You wanted to go over SQL as well, right? Should we have a look at some SQL? Bonus points. Anyone know where Slarty Bart Fast is from? Guy in the online open day at Bath pronounced it as SQL. Well, he's wrong. He's probably a Windows user. That's like the level of wrongness. Anyway. Right. So, SQL. Do we know where Slarty Bart Fast is from? I'm disappointed that you don't instantly know. Yes, it is. HHGTTG. Interestingly, what is the thing linking 500 Days of Summer and The Hitchhiker's Guide to the Galaxy? Does anyone know? A little bit of pop culture trivia in this live stream here. Not a clue. In the I want to say recent, but it's not really that recent. In the Hitchhiker's Guide to the Galaxy movie, which was made Hitchhiker's Guide to the Galaxy. In the movie, which was made in 2005. Christ, is it that old? Anyway, in the Hitchhiker's Guide to the Galaxy movie, Trillian was played by Zooey Deschanel. So there you go. Another reason to watch it. She's a very attractive woman. If I haven't already mentioned that. Yes, the floating point is here. Let's have a look at SQL. We don't need to go over what a database is. You know this. Structured language. It's like pseudocode. I mean, it's not like a full programming language. It's used to query databases. There are some pretty radical things that you can do with it, though. I'll turn my... It's a bit bright outside. There's some pretty radical things you can do with it, but you guys don't need to know an awful lot about it. You need to know create table, alter table, insert, update, and select, apparently. I think you also need to know join. Pretty sure you need to know join. But yeah. I'm going to make a game in SQL. I mean, I guess it's not beyond the realms of possibility. Just having a quick check. Oh, what? The SQL murder mystery? The SQL murder mystery is designed to be both a self-directed lesson to learn SQL concepts and commands and a fun game for experienced SQL users to solve an intriguing crime. Well, this sounds amazing. Okay, I'm going to have a look at that later. But yeah, so do I want to go through all of that? Right, so let's have a look at the create syntax, okay? When you create a table, because you don't need to know how to create databases, look to the spec, it adds so many commands on it. I don't think it's got that many, not when it comes to SQL. I tell you what, give me a second. Let me load it up. That's not the Google Classroom. Where's the Google Classroom? Where is the specification? Ear level specification. Let's find SQL. I'm not saying that because that's what it's called. I'm saying it as I type it in. Right, select from where. Okay, so it's got a lot of commands, but these are all there. Like things like from and where and like and or, they are not sort of like commands in their own right. They're used as clauses within these other commands. Okay, so you need to know select, you need to know delete, insert, drop, and join. Those are the main commands. So you don't even need to know alter table. Okay, interesting. So when you don't even need to know create. Okay. I can skip over create then. So let's allow that. Don't need it. Insert into users. If you've got a table, right, and you want to stick some data into it, you use insert. Okay. Now, the way that insert works is you say insert into and then you specify the name of the... Yeah, wildcards is not a command. I'll get to that. You specify the database table that you're inserting it into. And then in brackets afterwards, you specify which of the attributes you are going to be inserting. Because you can, depending on how your table's structured, I've got to take this off now. Depending on how your table's structured, you can potentially leave columns blank, or if you've got an auto increment ID or something like that, you don't want to fill that in. So the bit in brackets tells you what data you are inserting, what fields you're inserting your data into, right? So insert into name of database, bracketed list containing the attributes that you're inserting, and then values, and then another bracketed list, comma separated, containing the actual data that you're putting in there. Okay, so yeah. Right, so when it comes to SQL, it's not case sensitive. The convention is to type commands in capital letters to aid readability, but it's not case sensitive. So this command here will insert some data into the users table of our database. It's going to insert the text Carol into first name, it's going to insert Danvers into last name, and it's going to insert the integer value 38 into age. Does that make sense? Okay. Oh, where's my pointy thing's gone away? There we go. Oh, I can turn it on and off just by using the L key. Sick. Okay, so obviously insert is if you don't already have data in there and you want to add it in there. Captain Marvel kind of cringe. I mean, it was a crap film. I think I created this PowerPoint before the film came out. It might have been, I can't remember, but the comic book was better. But I think that describing things as cringe is super cringe. So there's that. So if you've already got data in your database but you want to change it, you don't use insert, you use update, which makes sense, right? Now you have to set some, well, you don't have to, but usually when you're updating some specific information, you want to set where you are actually updating it, right? So update users, set age equals 37. If I just had that on its own, if I just had update users, set age equals 37, right? Then it would set the age of literally everyone in the users table to 37, which is probably not what we want, right? So what where does, and that's one of the things that's on the spec here. It says where. That's not a command. That's a clause that you use. So where basically says here's some criteria to help you find the specific thing that I want to update. Right, so update users, set age equals 37, where first name equals Carol and last name equals Danvers. So and or logical operators, they work in exactly the same way as and or do everywhere else that you use them. So if it's going to search through your table and it's going to look for the record that has the first name Carol and also the last name Danvers. So if you're called Carol Decker, who used to be a very attractive woman. Is she still alive? I don't know. Singer from T'Pau. What an act. What an act. Massive crush on Carol Decker when I was a kid. So first name Carol, if she has her last name Decker, it's not going to update that. Likewise, if you had, I don't know, John Danvers, not John Denver, but John Danvers. Again, one of them matches. Both of them have to match. So it's going to search for wherever there is a Carol and a Danvers and then set their age to 37. Now, it might be that there are multiple Carol Danvers in the users table, in which case all of them will have their age updated, right? So if you know the specific user ID of the person whose data you want to change, you would use the user ID. And in fact, most of the time when we're doing updates, we will probably want to update a specific record based on the user ID. Does that make sense? Update. So insert to add data, update to change the data that's already in there. Where is a clause that allows you to pinpoint which data you're accessing, and is just a logical operator. That make sense? Cool. So select is another one that's on the list. Select is one which you also need to know at GCSE, but I don't think, not sure we covered that, but Kabah. What on earth does that mean? So select star from users, right? This star here is an example of one of those wildcards it mentions. Okay, so wildcards in capital letters is not a command. When it talks about you need to know wildcards, it means using these symbols to mean everything. So select everything from users. The asterisk is the wildcard symbol for the select statement and various other statements as well. Okay, so select star from users will pull out literally everything in the users table. Okay, now obviously we can apply the where clause in here as well if we want to pull out just specific criteria, which, let's be honest, most of the time we want to if we're searching a database. I'm pretty sure that when I searched IMDb for The Hitchhiker's Guide to the Galaxy, it probably would have run a command similar to select star from films where title equals Hitchhiker's Guide to the Galaxy. Obviously not that exact statement, but something vaguely similar to it. So let's just have a quick look at some specifics of the select statement, right? Select first name, last name. So instead of using select star here, I am saying specifically which fields to pull out. So instead of pulling out everything, I'm just pulling out the columns first name and last name. Do you have to select something before you can do anything with it? Yeah, I mean, select is the way that we pull information, we query the database and get information from it. So if you want to actually, publish that information, do some work with that information, then you'll need to do a select. Okay, and you can chain these things together as well. So you might select a bunch of information and then use that as part of an insert method or something to shift stuff around the database. Yeah, you select this. You'll change some. You'll either display it if it's just the user querying something. You can select it to pull it out to populate like a form or something like that. And then when you edit the data, it would just be an update or something like that. There's various different things that you can do with it. Okay, if you're accessing a database, like the way to change data in a database is with update, right? The way to view data in a database is with select, and with a combination of those two, you can pull data out and you can stick it back in again. Okay, bear in mind the select. I say pull it out. The select statement doesn't remove anything from the database. It just displays it for you. So select first name, last name from users. It's going to pull out this column and this column from the users table where age between 10 and 50, right? Pretty straightforward, right? It's going to note that it's not going to tell you what the age is. The only stuff that we're pulling out is first name and last name, right? But it's going to search for all of those ones where the age column has an integer value which is between 10 and 50. And I believe SQL, those ranges are inclusive. If you want to update something, do you have to select it first? No. You can just run an update. You can update whatever you want, whenever you want. You only need select if you are if you wanted to view the data. Now, obviously, most of the time, if we've got some sort of interactive interface to the database, we'll probably want to see that data before we modify it. So you would use a select statement to fetch the data and then display it on the screen. And then when the user changes it, you then issue an update statement to stick it back into the database, the modified values. Okay. So we've also got this down here. This is another example of a wild card here. Different wild card though. There's two wild cards that you need to know. You need to know the star, which is like the wild card for your field names. You also need to know the percent sign, which is the wild card for text. So select first name, last name from users where first name like C percent sign. What that means is it's not an exact match, but it will start with a C and then it will have any other characters afterwards. Yeah. So that percent sign basically represents any number of any character. So it's going to pull out all of the users with a first name that begins with C. Yeah. You could also do like, all of the users whose last name ends with S or something. You could say where last name like percent %S or any variation thereof. If you wanted to check to see if they had the word and anywhere in their name, you could put percent sign and percent sign, and then if the letters, that would pull out people like Randy Orton and Randy Savage. I don't know why Randy is the only name that I can think of. I was going to say Randolph, but that's just the long form of Randy. What other names contain the word and? Amanda Hug and Kiss. I need Amanda Hug and Kiss. Yes, that was a Simpsons reference for you there. Okay, so we get what's going on with select, yeah, and the where clause and the between and the Andrew's an example, yeah, and we get the concept of wildcards, right? So that's covered select, from, where, like, and or. Insert. All you need to know now is delete, drop, and join. And I believe that is what I've got next up on my thing. Oh, you need to know about nested select statements. Might take a little while to get your head around. Is SQL case sensitive with the data it puts in, pulls out from the database? Well, yeah. So the language itself is not case sensitive, but remember, if you're sticking in a string, it's gonna stick it in whichever characters you put in there. Now, if you've got your database set up, there are a wide variety of different text data types, some of which are case sensitive, some of which are not case sensitive. So it all depends on how you got your database set up. In terms of like knowing this for A level, it doesn't matter. You can just you're not going to get marked down if you put a capital letter in your strings or something like that. So yeah, this is a nested select statement. Okay, and it's fairly logical the way that it works. We've got select star from users where user ID in, select star from users where first name equals Bob. Okay, so we are running the inner select statement first. So we're doing select star from users where first name equals Bob. So this is going to pull out everything from the users table where the first name is Bob, and then it's going to, this is a stupid, why did I come up with this? This is a really stupid statement because we're checking in the same table. Anyway, this is basically going to pull out all of the information from the users table where the user ID is in this. That are really what this should say. You know what, I'm going to... it's still not a great idea because you're doing a nested select statement on one thing, but whatever, we'll work with that. So it's going to pull out all of the user IDs from the users which have the first name Bob, and then that is the data set that it's going to use here. So that's basically where user ID in whatever the result set of this select statement is. That's what it uses. So instead of instead of having a separate clause like specifying something like this, you're basically saying, oh, here's a data set from another select statement. Does that make sense? Like I said, it's a pretty terrible example that I've put on here. I feel ashamed of myself. But I don't think you're going to have to worry too much about that. You don't need to know about alter table, so we're not going to bother with that. Right. For the purposes of this next example, we're going to assume that the table has this structure. My coffee has gone cold, and that bothers me. In terms of the lines, it doesn't matter. SQL's not picky about the lines or spacing or anything like that. You can do all of it on one line. You can split the lines up in weird and wacky positions. Doesn't matter. Okay, it strips all of that stuff out. Remember what we were talking about with the lexing? It builds up a token stream and it treats all white space with equal contempt. Yeah. So we're going to assume this structure. We've got a users table which has got 3 users in it, and we've got an orders table which has got 3 orders in it, which are linked to some specific user IDs. Wow, that coffee. Oh. Yeah, that's made me. Oh, I feel faint now. Okay, so you need to know about the join command, and the way that works is you can use join within your select statement in order to effectively join 2 tables together, right? So if I use this statement here, select name, order ID from users, join orders, right? It basically means instead of just selecting it from the users table, join the users table and the orders table together, and the column that you're going to use as the reference point is the user ID column, which makes sense, right? So if we just go back here, you can see we've got user ID 1, name Bob, user ID 2, name Jim, user ID 3, name Alan, and then we've got the order ID, and we can see that here we've got a user ID 2. Well, we know that that's Jim if we look across there, right? We've got another user ID 2, which is also going to be Jim, and then we've got a user ID 1, which is going to be Bob. So when we join them together, basically all it's done is stuck on the users column onto the the users table onto the orders table, and you'll notice that Alan doesn't appear in it. Why doesn't Alan appear in it? Because Alan's not got a user ID in the orders table, so there's no point sticking his stuff on there because there's nothing to link it up to. So users join orders, the joined table looks like this. Here's all of the stuff from the orders table and all of the relevant stuff from the users table joined on the common field, which is user ID. Okay, so users.userid equals orders.userid. That's saying the user ID field from the users table should match up with the user ID from the orders table. Okay, so it's joining users to the orders table using these as the joining point, and then once it's joined that table together, it just becomes effectively a standard select statement. So we're going to pull out name and we're going to pull out order ID from this table, where orders.orderDate, notice that for each of these statements I've put the name of the table in front of it. You don't really have to, you could just put order date, but we're saying if it's greater than 2016-11-1. So that is going to pull out all of that stuff, it seems, because they are all greater than that. So it's going to pull out Jim and order ID 1. It's going to pull out Jim and order ID 2. It's going to pull out Bob and order ID 3. No, the semicolons at the end, because this is all one command, right? If I was to write this all on one line, if I've had to necessarily split it up onto multiple lines because of the because of the what's it called, the limited space on my slide here, right? So select name order ID. There's your select statement. The from clause is from users join orders on users.userid equals orders.userid. So everything from here, from the from all the way down to here, is the joining bit. Okay, so that is not the end of a statement there. You can't just say users join orders. That doesn't mean anything. You've got to have this criteria as well, and then the where clause. So if I didn't have that where clause on the end of it, it would just return this table. I mean, as it stands, it's still going to return that table because our criteria is a little bit silly. So on tells the system what the common ground is. What are you joining the tables based on? We're joining this table, we're joining that table. What are we joining them on means what is the column that we are going to use to link them together. Okay, so we know that user ID refers to the user ID over here. Almost always your on will refer to it will be a linking of the foreign key and the primary key of the other table. Okay, so it's joining these two tables together on this value here. That's why we have this with Jim on there, we have that with Bob on there, we have that with we have that with Jim, we have that with Jim, we have that with Bob, and Alan doesn't get joined on. Makes sense? Only a couple more. Right, delete. Delete does not delete database tables. It deletes data from database tables. So this is the opposite of insert, if you like, and the syntax is, I guess, reasonably similar. It's reasonably similar to the update. Delete from users where user ID equals 1, right? That is going to delete the entire row. It's going to delete the entire record from the user ID, from the user table where the user ID is 1. Okay, simple. And remember what we talked about referential integrity. That means if that user ID is used as a foreign key imported into any other tables, there will be a cascade effect, which means that all of that data gets removed, so that we don't have any orphan data. Do it make sense? Makes sense. Cool. I think the only other one is drop, and I have not put this on here because I didn't realize that you needed to know drop. But drop is the opposite of create. So something like drop table users, say goodbye to your users table. Okay, so things to remember: delete will delete data. Drop will delete the entire thing. You can also do drop database if you want to completely eliminate the entire database. Does that make sense? There's your quick crash course in SQL. Cool. So you wanted to go over some internet stuff. Are we good on databases now? Is that databases all good? By the way, this was the website that I found, the SQL murder mystery. I do love a murder mystery. I don't know. I haven't played this, so I don't know if it's good. But I'm going to investigate that, and I'm 100% using it in my lessons if it's a good resource. So let's have a play around with that. But yeah, I suspect it might go a little bit more in depth than the A-level stuff. Right, wicked. Shall we do some internet stuff? Right. Right, so Kira mentioned domain names. I can't remember what other internet-related malarkey people had mentioned. What is there anything specific other than domain names? Anything specific? Do we need to know that much on domain names? Well, I'll tell you what, let's have a look at the spec. Bear with me while I just double check. Apologies for that. Sorry, there's something up with my mouse. Oh god, what's happening? There was a question that asked how they are indexed. Let's just have a look. About all I can play before copyright destroys me, so let's just have a subdomain.domain.slud.tlud. Do you know what? I'm searching in the spec. I can't find the word domain. You need to know about DNS. So in the network section, it says characteristics of networks and the importance of protocols and standards, the internet structure, the TCP/IP stack, DNS, protocol layering, LANs and WANs, packet and circuit switching, network security and threats, use of firewalls, proxies and encryption, network hardware, client, server and peer-to-peer, HTML, CSS and JavaScript, search engine indexing, the PageRank algorithm, server and client-side processing. So I guess it falls under the category of what's it called? DNS, I assume. So let me see what do we got here. We know that the internet and the World Wide Web is not the same thing. I'm not going to advertise NordVPN. We know about latency, right? We know how annoying high latency can be because when you click on your stupid slideshow, it takes ages for the things to appear. What's latency measured in? What's latency measured in? What's it also known as? Ping, yes, and it's measured in milliseconds. Excellent. Right. Right. People have this weird view of the internet in that it looks like a frames win games. I disagree with that statement. the internet obviously doesn't have a physical appearance. It doesn't look like this, although this is a reasonable. Well, this was 2010. The landscape's changed quite a lot here, but this is basically sort of like this is a zoomed in bit of this bit of the map. You can see email. Still, the vast amount of traffic on the internet is email. It doesn't even look like this. But this is sort of, and even this is outdated now. This was 2006. You'll notice that there's these grassy areas laying fallow. That's to indicate bits of the internet where the IP addresses hadn't been assigned. It's all been assigned now. But the thing is, this is closer to what the internet looks like than this, because this is showing the breakdown of different IP address ranges and where they are registered. Okay, so you can see like this is how like Netflix stops you from watching like shows that were available in America and not in Europe, because it looks at your IP address. Like my IP address starts with 81, and that's in a block allocated to Europe, you know. But if you use something like NordVPN, you can spoof your IP address. So it might be a 207 address, which would appear in North America, and then they're like, "Oh yeah, cool, you know, here's your American TV." All right, but we are crap. As human beings, we are terrible at remembering numbers. Right? But we're pretty good at remembering words. Yeah? So we've got this IP address 212.58.249.145, which I think is a Google a Google IP address. Let me just ping that. Ping 212.58.249.145. Okay, it exists. Maybe I'll trace route it. Where is that going? Oh, what? I don't have trace route. Oh, I do have trace route. I was using the wrong command. Yeah, it doesn't actually say. Interesting. Service, not server. Yeah, I mean, I don't think anyone's going to... I don't think anyone's going to mark you down for saying service, saying server rather than service. But the thing is, a DNS server, a domain name service server, is almost tautological. So the machine would be a DNS, you know, domain name server. But yeah. So what DNS does, it basically has a list of these IP addresses, right? And it matches them up with the text-based names. If I just ping www.google.com, I get 142.250.200.36 is the IP address that gets returned, right? What's happened is it sends out my request to the DNS server, and it says trying to reach Google.com. Where is that? And the domain name server says, wait a minute, let me just have a look at for you. It is 142.250.200.36. It's basically like a directory service. So we're not going to bother doing that. But the way that the domain names are broken down is reasonably well structured. Okay, so we have our domain bbc.co.uk. That's the domain. Sorry, I'm in the middle of something. Family members asking me stuff. So we've got the domain. Everything that will be linked to a specific IP address. We've got a subdomain. The subdomain is a specific area within that domain, right? So you might have www as your subdomain. Most web services will have www subdomains, right? But they don't have to. For instance, I'm using Google Docs. That's docs.google.com, which takes you to an entirely different place compared to www.google.com, right? In fact, I wouldn't be surprised if they were actually registered as different IP addresses. Let me just have a look. Ping docs.google.com, 142.250.187.206, yeah, which is different to www.google.com, which is 142.250.200.36. So similar, but not the same. The subdomain is sort of like what's below the main domain. We've got this second level domain, which usually gives you some information about the type of company. So if it's a commercial business, .co or .com, if it's academic.ac, which stands for academic community, if it's a government URL like .gov. Time was when that rang true, but it was sort of like, like .net should have been reserved for internet service providers, but there's a lot of people that just use .net. And then the top level domain here is usually a country code. This will be one of those areas that I showed you before in those little boxes. This will be a range of IP addresses that are reserved by a particular registrar in a particular country. Does that make sense? Right, this whole thing together is what's known as the fully qualified domain name. Yeah, or FQDN. I don't think you need to know that particular nomenclature, but understanding the structure of a domain name. The structure of a domain name and how DNS is used to look up IP addresses associated with those domain names. And I don't think you need to know DNS in any deeper level other than it's a service which matches up the text-based names that we are good at remembering with the numerical IP addresses that we are not that good at remembering. Makes sense? Makes sense, says George. Do we need to know about polymorphism? Yes. Is the short answer. Let's have a look at the spec again. Polymorphism. Object-oriented languages with an understanding of classes, objects, methods, attributes, inheritance, encapsulation, and polymorphism. Can we go over polymorphism? Yeah, sure. So polymorphism is basically it's very similar to inheritance, with the difference being that when you're using polymorphism, you tend to use an abstract superclass, and each individual subclass will has to implement all of the things that are in it. So let me find. Should we go over? Where's my? I had PyCharm open. I don't know what I've done with it now. Oh, I closed it because it was eating CPU. Give us a second. I can give you a quick whistle-stop tour of network hardware before launching into polymorphism. Give us a second. Oh no, we're not watching a packet style. You've seen that a billion times. I need that. No. Okay, might need that. What is the other thing I was gonna look for? Network hardware. We'll just do a quick blast through of all the different pieces of network hardware you need to know about. Do. Yeah, we could do an example of polymorphism. I use the animal example. Right, network hardware. Go away, Python. What are you doing? Network hardware. Let's have a look at what we've got here. We've got a router. The router is used. Try and avoid saying a router is used to connect to the internet, although that's primarily how it's used. That's not what it's for. What the router does is it connects two different networks together. Two different networks that use the same protocol, I might add. So really, a lot of your routers probably aren't actually routers, but are actually gateways. So I'll have a look at gateways later. So if you have a LAN and you want to connect it to another LAN, you would use a router to connect it. And what the router does is, as the name suggests, it will send the packets of data to where they need to go based on the best route through the network. Okay, so the packets come in on the link layer. The router then strips off all of the link layer stuff. It will then have a look. It will look at the IP address. It has routing tables on there with like traffic reports and stuff like that, so that it knows the best route to send the stuff down there. Do gateways change just internet and link protocol stuff? Yeah, I'll get onto gateways. Switch. We know about the switch. Well, so I'll get onto gateways when they come up in the thing. Switches, they are the center point in a star topology. That's this bit here. Okay, the server is not the central point in a star network. It bothers me that a lot of people draw it like that. That's not how it works. So a switch is not the same as a hub, although it often appears in the same position as a hub. It connects all of the different nodes together on a star network. It also directly sends the packets to the specific machine that it's intended for. Unlike a hub, which is dumb, the hub just sends stuff to every single node. It still connects nodes together, but here's a crap animation, which I'm sure you've seen before. So the switch is sending information from the source directly to the target, which means it can potentially send data like from one machine to another machine and another machine to another machine at the same time, whereas the hub will send out the data to every single machine, and the intended machine will say, okay, cool, that's mine. So obviously hubs are way slower than switches, and it's quite rare to see a hub these days. They used to be super cheap, but now they're super, no one buys them because switches are way cheaper. Network interface controller, network interface card, the NIC. This is the thing that converts data from like binary ones and zeros into physical transmissions. So this does all of the link layer protocol stuff. It has a MAC address. This is the MAC address of your machine on the network will be whatever the MAC address of the NIC is. So if you get banned by MAC address, if you change your NIC, you will no longer be banned by MAC address because it will have a different MAC address. This converts it into electricity or light or radio waves, whatever it is that you are using to send it out, and then it sends it across. It also receives it, converts it back from like the physical format into ones and zeros. Okay. Do we know what these things stand for? Twisted pair, coaxial, fiber optic, Wi-Fi. So on the subject of cabling, I think this is the wrong. I think this is the wrong presentation, but we'll soldier on regardless. We've got a twisted pair cable made out of copper, multiple strands twisted together. One for send, one for return. They're twisted together to reduce interference. Coaxial cable, you've got a single copper core with a dielectric around the outside and a sheath. Fiber optics sends light, not electricity. It's made of glass. Uses the principle of total internal reflection. Super fast, way more expensive. Boom. I'm going to go over that. The air, that's your Wi-Fi transmissions, radio transmissions. Wi-Fi channels, right? Because Wi-Fi is basically radio waves. Yeah, they have a specific frequency, and when you broadcast on a specific frequency, there's some fall off, right? So there's some crossover between these channels. Yeah, if I'm broadcasting on channel 3, that means that my frequency is what, 2.423 gigahertz. You know, but that does it's the range. It's the range of transmission frequencies between 2.4 and 2.43 something or other. Okay, and so there's some crossover here. And if you are broadcasting on a channel that has a lot of other people broadcasting on that same channel, the air still has limited bandwidth, right? In the same way that your cables have limited bandwidth, the air also has limited bandwidth, right? So if you analyze your Wi-Fi, find out how many different signals are being broadcast on each of the channels, find the channel with the least amount of overlap and switch your broadcast to that channel. It means in theory you could get faster transmission speeds across the wireless link. Does that make sense? bear with. Let me just find the other presentation. That's the one. Here's the one. You wanted me to go over. Right. So let's have a quick deep dive on the difference between gateways and routers. So routers operate on the internet layer of the TCP/IP stack. Okay, so they're not dealing with MAC addresses; they're dealing with IP addresses, as opposed to switches. Switches operate on the link layer, so they're dealing with MAC addresses. Yeah. This one is the gateway. So the gateway is like a router, but instead of joining two similar networks together, it joins together two networks with different protocol sets. Okay, so what the gateway does is it still operates on the internet layer, strips all of the headers like right down, so it will open up all of the packets. It will then repackage them according to the new set of protocols, and then send them back down to the bottom layer, and then send them on. Okay, so whereas the router is reading those TCP IP. It's reading the IP packets, and it's saying, right, okay, where does this need to go on this IP network? What the gateway is doing, it's like maybe opening the IP packets and saying, right, where does that need to go? Let's convert it to this other protocol. I don't know, point-to-point over Ethernet or whatever. Package it up again, and then send it along the way. Okay, I don't think you need to know it in that amount of detail. You just need to know that routers are used to connect two similar networks together. Gateways are used to connect two separate networks which use different protocols. Okay. Is there anything else you need to know about? This is a hardware firewall, by the way. So firewalls, you're probably used to software firewalls. You can get hardware firewalls, which are like, you know, specific pieces of hardware. But you know how firewalls work, so I don't need to go over that. Proxy servers. The proxy server is the thing that accesses the internet on your behalf. So you say, can I see this web page, please? And the proxy server, rather than like sending your request directly out to the network, it processes it. It says, right, are we allowed to actually do this? Okay, cool. Yeah, right. I'll go and get that. The response comes back to the proxy server. The response is then checked before it's sent back to the person originally sending it. That's how your internet blockers and stuff at school work. But I believe this is all shared up anyway. So do I have a proxy server on my home computer? No, you don't. I mean, unless you've set one up, you can set up proxies at home. But I would imagine that you are probably not running a proxy. What's happening is your messages are being sent to the router and then directly sent out to the network, and then when they get back to the router, they're being directly sent back to you. There is no intermediate within there. Don't think there's anything else I need to go on about. Is that all making sense? Each channel occupies a range. Yeah, so each Wi-Fi channel occupies a range of frequencies. Is this all good? Need anything else? Apart from the, what's it called? Polymorphism. I think I've got some stuff on polymorphism down here. Right, my question for you is this. Do you understand inheritance? Because if you don't understand inheritance, you won't be able to understand polymorphism. You get inheritance. Okay. So I will explain this more fully when I've got back from the toilet, because I'm absolutely bursting. Has Farrell had a stroke or something? Wick'll be back. Ick'll let you know again backsk. Nice one. Nice one. Right, so I'll be back in just a second. Do you want some calming music while I'm gone? Let's find some calming music. Do. Gonna get some food and drink. Right, let's play YouTube's official theme song, which I believe is, you probably recognise it. Right, I'm back. How about that song? Are we all here? We're ready to go. What song is it? It's known as the YouTube theme song. I think the actual title is 009 Sound System Dreamscape. It was used in like 1,000,000,001 YouTube tutorial videos, like in the mid 2000s, because, and this is the reason why, loads of Minecraft tutorial videos and stuff, because they'd used like copyright music and then they got a copyright strike, and so they needed to get some copyright free music, and because it's called 009 Sound System, it was the first tune in the list of royalty free music that you could instantly click on in YouTube editor, and so everyone was just like, yeah, whatever, use that. So there's that. But yeah. It's a good song. I'm not sure it's a good song. Anyway, right. So polymorphism. Polymorphism is it's essentially a form of inheritance, but whereas with inheritance you might inherit the whole thing and maybe have a couple of extra methods, or you might override one of the methods or something like that. With polymorphism, the subclass will override all of the methods of the superclass with its own functionality, right? And if we're talking about pure polymorphism, this superclass will be abstract. So it will have a list of all of the different methods that need to be implemented, but there won't be any implementation in there. If we know that we are going to need a lot of similar classes, but we don't know exactly what types until we run the program, then polymorphism is a good idea, because we know that everything that inherits from this superclass is going to have the same sort of like way of interfacing, right? But the specifics are going to be slightly different. Okay, so we can set them up, and then we can just say, oh yeah, this is a bus, this is a car, this is a train, or something like that. Right, so here's an example. I'm not sure I want to use this example though. You know what? I used the vehicle example before, didn't I? I used the vehicle example before. Give me a second. Let me just quickly code something up here. Do I want to use the animal one? No. Right. I will just quickly knock something up here. In fact, I'm pretty sure I've got my because I went over object factories with you before, right? Did I go over that? Did I go over that? Yes, I did. Right. So let me just quickly, because if I can pull that one down, it will save me a lot of typing. Let's see if I can just grab that. Let's log in. A level. What the hell is this? This is... There we go. I think that's the one. Yes. Yes. Right, let's just sort my view out here so you can actually see what's going on. Boom. Can we see that all right? Is that okay? Is that text large enough for you? If I just go through this this example here, I've created a class called vehicle, right? And this is an abstract class, right? It's got a method called drive. But if you try and just create a vehicle and then drive it, we're going to get this error. It's not implemented. The subclass must implement a method, right? So tanks are a type of vehicle. We can see tank inherits from the vehicle class. Cars are a type of vehicle. Car also inherits from the vehicle class. They've each got their own specific constructor here, which basically just tells us whether we created a tank or whether we created a car. right? But you'll notice both of them have drive methods. Both of them implement that drive method there. So in our vehicle class, we say there has to be a drive method in there, but we're not implementing it here in the vehicle class. Every class that inherits from this must implement their own must implement their own version of it. Okay, so the beauty of this is we can randomly choose to create a vehicle of a random type. We don't know what type of vehicle we are going to get here. This static method, the factory method, basically what it does is it will randomly choose it takes a type that we specify. So down here we're either specifying a car or a tank, and it will create a new instance of a tank class, or it will create a new instance of a car class, and it will send them back, right? So down here we create a vehicle and we assign it to the variable vehicle. At compile time, we don't know whether it's going to be a tank or a car. But at runtime, we randomly choose car or tank. The factory class is called, the factory method is called, I should say, and it will either send us back a tank or send us back a car, regardless of whether it's a tank or a car, because they are both vehicles. They've inherited from vehicle. We know that they have a drive method. They've implemented their own version of the drive method, so we are quite safe to say vehicle.drive, even though we don't know whether it's a car or a tank, right? So if I run this, you can see first one, we created a tank. The tank crashes along. We then created a car. The car races along. Created another tank. The tank crashes along. Created another tank. The tank crashes along. Notice that the loop, it hasn't changed, right? We're still using the vehicle. We don't know what we're going to get. We're always just doing vehicle.drive, right? Because they are both they've both inherited from the vehicle class. Kind of like a prediction. It's more like a it's not a prediction. It's more of an interface. It's a template, if you like. We are saying all of the classes that inherit from this class, will have this functionality. So regardless of what it is, you can interact with it in the same way. And just like how if you buy a bike, there's many different types of bike, right? But they all have the same sort of control method. You have handlebars, you have brake levers and stuff like that. Or another example, there are many different vehicles that use a steering wheel. Like, a car uses a steering wheel, a van uses a steering wheel, a bus uses a steering wheel. So regardless of which one you are driving, they all drive in different ways, but you use the control interface in the same way. I'm not sure what you mean by looser inheritance. If anything, it's tighter inheritance, because if you're inheriting from an existing class, you don't have to implement anything, right? But with this, you definitely have to implement them, because the functions can work in different ways. Okay, right, I see what you're saying. But the thing is, the way that the functions work will always be the same. Likewise, if we had any parameters for our drive function, then we'd need those same parameters in the tank class and in the car class. So we know exactly how we are going to interact with the object, even if we don't know exactly what type of object it is. We know it's going to be a vehicle, and we know that all vehicles have the same methods of interaction. In the same way that all animals, right, have a mouth, yeah, and they have the opposite of a mouth as well, which is, I guess it's different in different things, but they all eat and they all excrete because they're all alive, right? So they will all have that function. The method of implementation is slightly different. Like, we eat in a different way to a jellyfish. We don't extrude our stomachs around the outside of the thing that we're eating and then withdraw it back inside ourselves. But a jellyfish does. Does that make sense? So polymorphism, just think of it as inheritance, but you have to implement the methods you're with each individual subclass. Does that make sense? That makes sense? No? Yes? No? Yes. Cool. So we've gone over database normalization, we've gone over SQL, we have gone over some network gubbins, hardware and stuff, and we've gone over polymorphism. It is currently just gone 8 o'clock. We have been going for about an hour and a half. How long have we been on? What time did we start? 6:10, nearly 2 hours. Been on for nearly 2 hours. 1 hour 55 minutes according to my clock, although a lot of that was nonsense at the start. Is there anything else that you guys desperately want to know about? A tip that I will give you: if you have to write something in pseudocode, it means you don't have to worry about syntax. You just need to worry about making sure that it is readable and there is no ambiguity. Okay, obviously make sure that if you're using strings, you've got quote marks around it. If you're using integers, you don't. Is that good? Are we going to sign off? What on earth is that hamster? What on earth is that hamster? Right, I take it from the fact that no one is asking any more questions that we're pretty good. Polish bonsai, buddy. Oh my god. Can we do one example of when we have to do operations with floating point numbers that have different exponents? What you mean, like adding them together? Yeah, we can do that. I'll just close Python. Let's bring up the old GIMP. Here we go. Operations with floating point numbers that have different exponents. So let's do something relatively simple. If we have 0, 0, 1, 1, 0, for some reason I am using 1, 2, 3, 4, 5-bit mantissa and 4-bit exponent. Look, don't just go with it. Just go with it, right? And we'll have 0, 1, 1, 1, 0, and we will make that 0, 0. 1 0. Okay. So we're going to add that. We're going to add that together. Oh, look, symmetrical mantissa. Right. So let's have a look at the stages here. Okay. We've got a mantissa of 0, 0, 1, 0. Oh, by the way, both the mantissa and the exponent are in 2's complement, so we're not dealing with any negative numbers. I'll keep it reasonably simple here. Right. So this exponent here is 1. Right. This exponent here is 2. Okay, so we've got 2 different exponents. We need to add these 2 together. Now, obviously, when we float the point, it's going to end up in slightly different positions. The easiest way of doing this is to work out the fixed point representation of these numbers. So if we start off with this first mantissa here, we end up with 0.0110, right? And the exponent is 1, so that point needs to float 1 space to the right there to give us our fixed point representation, which is 0.110. Okay? Now, with this other mantissa here, we have 0.1110, and our exponent is 2, so we're going to float the point along 2 spaces. 1, 2, it ends up there. Okay, so we end up with 0.11.10. Notice how I've lined up the binary point there. Okay, so now that that's all in position, we can add them up. Now, in theory, that's a 0 there, right? And that's a 0 there. Now we're dealing with the same amount. But one thing to bear in mind is that we now have too many bits for our mantissa, because remember, we're doing 5-bit mantissa. Now, that might not necessarily be an issue with this number, but bear in mind that if it's 2's complement as well, there's the risk of overflows and stuff when you add them together. But I don't really think that's going to be a particular issue. So we just add them together. 0 plus 0 is 0. 1 plus 0 is 1. 1 plus 1 is 0, and carry the 1. Here we go. We're going to end up with an overflow. 0 plus 1 is 0 and carry. 0 plus 1 plus 1 is 0 and carry. And then 0 plus 0 plus 1 is 1. But the problem here is, well, you tell me, what's the problem that we run into if we put a 1 there? Number too big. Well, I mean, yeah, number too big, but what does it mean if we've got a 1 at the start of our mantissa here? Yeah, it's going to be a negative number, right? So here's the problem with this. I mean, this was unintentional. I didn't choose these numbers thinking this was going to be an issue. We could in theory have an extra 0 on here there, and then that would become an extra 0 there, right? But because we've only got 5 bits for the mantissa, we're going to end up like losing some accuracy, because we'd have like 1, 2, 3, 4, 5, and that bit would go away. Obviously, the alternative is to lose that bit and just have 1, 2, 3, 4, 5, which is still like not really any good. So in this example, what I'm going to do is I'm going to stick those zeros on at the start there, and we will just we'll just lose some of that accuracy, basically. Okay, so the point is still there. So this is our total, 0, 1, 0, 0, 0.010. Now remember, we need to get the point to the second space along here. 1, 2, 3. So we floated it 3 spaces to the left, which means our exponent is going to be 3, right? And 3 in 2's complement 4-bit binary is 0, 0, 1, 1. Okay, so our final answer, with the lack of accuracy that we've got, is going to be 0, 1, 0, 0, 0, 0, 0, 1, 1. Okay, there's a normalized floating point number, which comes from the addition of 2 other floating point numbers with different exponents. Does that make sense? We good now. Wicked. In which case, my friends, I will say best of luck to you. Remember, don't stress out too much. If you're stressed out, you're going to do worse. So just take it easy. It's not the end of the world if you don't do amazingly well. This is your predicted grades are not solely based on the results of this mock. That's not how this stuff works. So obviously give it your best shot, see how well you do, and remember, it's a learning exercise. The whole thing is a learning exercise. I'm not going to judge your worth based on whether you do well on this test. I merely judge your worth based on what operating system you use on your home computers. Not really. I don't care what operating system you use. Okay, so here we go. Thank you very much for coming. Best of luck tomorrow. I will see you all. Whenever I see you.